Hey everyone, I'm back and we're going to flip back into some more math, and today I'm going to target another problem area, or an area at least that I see kids struggling in, and that's subtraction. So maybe you've already had, there's been words exchanged over some subtraction tasks that you've been working on with your kids. The reason why I feel like subtraction is a sticking point for some kids is because we try and rush them too quickly into a procedure for how to do takeaway. So I named it a number stack. So traditional old school parents are probably telling your kids, oh, this is a subtraction problem, you need to stack your numbers and you do takeaway. You're associating subtraction as only being a takeaway. And that's not really what subtraction is. It's part of the language that gets used when we're describing a subtraction problem. But what I'm going to focus on today is the big idea that subtraction is actually a difference between numbers. And I think, again, this is all my own observation and my own learning after having worked with so many different cohorts of students. I think why kids struggle to identify the operation of subtraction is because they get hung up on the language of takeaway. So you might be noticing at home with your kids being given a series of word problems and them not really understanding that what it is they need to do is subtract. So they might be able to pick out, no problem, all of the addition problems. So for example, Johnny has 6 apples, his sister has 8 apples, how many apples do they have together? They're able to look at that problem and go, oh, I'm going to add them together in order to get a total or a sum that's greater than the 2 products that were given. Where it starts to fall apart is Johnny has 8 apples, his sister has 2. How many more apples does Johnny have than his sister? So there's a lot of language in that, and it's really difficult for some kids to pinpoint that actually is a difference, and that the operation they need to select is subtraction. So I'm gonna broach this. I might end up taking 2 videos, but I'm gonna try and break it down for you where I see them getting stuck in why, as well as some strategies that are developmentally appropriate for introducing subtraction problems and helping them really understand that it's a difference between 2 numbers, and then actually subtraction problems can be solved with takeaway and backwards counting, but also we can use addition to help us find that difference. Okay? That was a lot, but I'll break it down for you on paper. All right. I haven't actually thought this all the way through as to how I'm going to break this down for you, but I'll start with the big idea, and that's that we subtract to show a difference between numbers. And that's a big idea that I feel like is not really ever explained to students, and maybe it's a novel idea for you as well. But that's really what subtraction is. It's looking at 2 numbers and the amount of space or the quantity between those 2 numbers. So I'm just going to write out a simple subtraction sentence. Let's do 9 take away 7 equals 2. So if you've watched my first video, then you hopefully already have an understanding that this equal symbols doesn't mean the answer, that it's a balance model, that whatever is on this side is actually the same as or equivalent to what's on this side. Looking at the difference between these 2 numbers is 2. So, okay. So when we read this out loud, we probably are reading it 9 take away 7 equals 2. So this is where the idea of the takeaway becomes associated with subtraction. So one of the best and easiest ways to work through a problem like this, a simple problem for a child who's just beginning with subtraction, is to actually draw it out or have counters or objects that they can use. So we're going to draw it out, and to add a story to that. Giving the numbers a narrative helps our kids make sense of what's going on. So I'm going to add a little bit of a story to this. So I have 9 cookies I eat 7 cookies, so now I have to show a way that to eat those cookies. 1, 2, 3, 4, 5, 6. I ate 7 of the cookies. How many cookies are left over? My answer is 2. So having the problem written out this way, giving your kids the opportunity to use counters in order to help them come up with the answer is really useful. Writing the problem in several different ways is also useful as well. So showing it to them like this is okay. 9 take away 7 equals 2. Where we run into problems by showing our kids this method right away is their lack of understanding that the number that's the higher quantity should go on top, because we have to be able to take away the smaller quantity from the top number. That's a really difficult concept for kids. So I call this the place value stack, and I try to avoid showing it to them or giving this to them until they actually have an understanding of what subtraction really is. Because you can tell them till you're blue in the face, the bigger number goes on top, but unless they know why the bigger number goes on top, you're gonna run into some problems. So instead, I would actually encourage you to use a number line. So just like in the last video, let's do this to 10. Divide it up, 5, 1, 2, 3, 7, 8, 9. Okay, so here's my number line, and I'm gonna actually place my products or my quantities up here onto the number line. So we've got, this should be 9, 8, 7, 6, 4. And I'm gonna show my takeaway this way, or my subtraction. So I've got 9 cookies, I eat 7. 1, 2, 3, 4, 5, 6, 7. How many cookies are left? 2. So 9 take away 7 equals 2. Rulers are really good for this, and what the number line does, oh shoot. Oh yeah, you can see it, just not very well. There we go. What the number line does is it helps the kids start to see that what we're really doing with subtraction is we're looking at the difference between these quantities. So the difference between 9 and 2 is 7. The difference between 9 and 7 is 2. Okay? All right, the other thing I wanted to show you, because this just got me thinking back to my first lesson as well, about the part-whole model. When we're working on a problem like this, we have our parts that make up the whole. And this is a little different than addition. So if I draw this model, when we look at the problem, we know that we've got 9 is our whole because I had 9 cookies, and I take away 7 of them. So how many are remaining? And this is really nice because in the model like this, when we don't have the whole and we only have the parts, 7 and 2 come together to make 9. So we can see the addition. A problem like this, when we're missing one of the parts, that's when our kids can start to identify that, oh, I have the whole and I have one part. In order to find the missing part, then the operation I need to select is subtraction. Either that, or I can add up in order to get my whole. So I'm gonna flip the page and I'm gonna show you what I mean by that. All right, so I put together a little problem. I'll read it for you. It says, Jack has been self-isolating for 45 days, and Megan has been self-isolating for 70 days. She's a bit of a keener. How many more days has Megan been at home? So there's lots of different ways that we can approach this problem. As a knowing adult, you look at this and you go, oh, well, it's subtraction. So I'm gonna take my numbers. I know that 70 is a greater quantity, so I'm gonna stack it on top of my 45, and you just do the takeaway, right? The problem with this, and the problem that you're probably struggling with at home, is that your kids look at this and say, well, I know I have to take away the 5 from the 0, but how is that possible? And what ends up happening is they start adding they start doing really weird things. They might even try and put the 45 on top of the 70 because then they can take away nothing from that and be left over with 5. And we run into all sorts of major misconceptions with this if they're not quite ready to understand what's going on here. You, being a really helpful parent, are going to say, well, all you have to do is you just cross out this 7, and then you add a 1 here, and then you take away the 5 from the 10. Where we end up, I notice with kids, is they see this and we're adding the 1, but they have no idea why we're adding the 1. And it's not 1. It's actually 10. We've taken one of these 10s, we've broken them down into small individual 10 units of 1, and then we have to subtract away 5 1s from those 10 1s. Whereas we look over here and we've got 7 10s, which is 70, and 4 10s, which is 40, not 4. Okay, so that's a lot, and I get that might be super confusing when you just know to follow the procedure. But we're looking for helping our kids understand what's actually going on with this problem. Pulling the numbers out of a word problem and stacking them on top of each other doesn't give them an understanding. It doesn't actually help them visualize this problem and see the story that's there. So I'm gonna lay it out for you differently. Okay, let's make sure you can see. All right, so instead, I'm going to read this problem out loud one more time. Jack has been self-isolating for 45 days, and Megan has been self-isolating for 70 days. How many more days has Megan been at home? Well, if I'm fluent with my number line and the order in which numbers flow and my counting, I really could lay it out like this. $45 and 70. What is the difference between those two numbers? I'm good at skip counting, and I've actually been very kind and I've used some friendly numbers, 45 and 70. We've rounded to an even 5 and an even 10 over here. Numbers that our kids are usually fairly confident skip counting by. So now I'm looking at the difference. How many more days has Megan been there than Jack? And this doesn't even have to be a subtraction problem. I can use addition in order to solve this and find the difference between these two quantities. So I'm going to use what I know about 45, and I'm comfortable counting forward, more comfortable than I am going backwards. So I'm going to add 5 to make this, I guess I should make that even, to make this 50. That's way more friendlier even than 45. So I'm gonna add 5 to make 50. I know I can add 10 to make 60 and another 10 to make 70. The difference between 45 and 70 is 10, 25. Or can you see? My whole was 70. One of the parts I knew was 45. The missing part that I didn't know, the difference that's missing, was 25. And it was really easy for me to see and conceptualize on that number line. Makes a lot more sense than this. Now, eventually your kids will be ready for this, but what needs to go with it is the understanding that I'm not just taking away or adding, crossing the 7 out and adding a 1. I'm actually breaking that 70 apart. So I'm just going to slide this here. So I'm going to show 70 take away 45 using some counters. Now I don't have base 10 blocks with me, but I can draw them out. So your kids should be familiar with the rods at school that are broken into 10s. Now this isn't going to be very good. 1, 2, 3, 4. So there's a rod worth 10. And I'm just going to draw them out quick. I know the value of each of these is 10. 1, 2, 3, 4, 5, 6, 7. So I've got 70 with my rods, and I also, now I need to take away 45 from my 70. So I can take away 40, no problem. I have to break one of these rods apart down into, so I'm going to take this rod right here, and I'm going to break it apart into 10 ones. Now that it's broken apart into 10 ones, see how I got rid of that? I took one of those away and added it over here to make it 10 ones. Now I can take away 5 from those 10 ones. Okay. And my leftover total is 10, 20, 20 plus 5 to make our 25. All right, so there's a lot, this is a super fast version too. There's a lot going on with a place value stack like this. Our kids need to know and understand what's actually happening with those numbers. I'm not just crossing out 7 and adding a 1. That's 70. And I'm taking one of the 10s away from 70 to actually be left with 60 plus 10 ones over here. So your kids might very well be ready for that, but I would still encourage them to have these types of manipulatives available. If you don't have them at home, which I can't imagine many of you would unless you're a teacher, you can get printouts online of the base 10 materials or have your kids draw them out like this. However, I want you to try some more problems using the number line. And I'm gonna next model a quick game for you to try and reinforce this skill and some really quick thinking about how subtraction is actually a difference. All right, welcome to my Diffie. All right, this is a little game that I get my students to play to have them practice understanding that subtraction really is a difference between numbers, and that we can use addition or takeaway in order to help us find the products that we're looking for. So it's super easy. You can play as long as you have a blank piece of paper and you get comfortable writing out the shape of the Diffie, but you're going to start with 4 corners. And I would suggest choosing 4 friendly numbers the first time you play. And when I say friendly number, just like in my previous problem, I want you to pick a number that your kid might feel comfortable with. So they may feel comfortable with 10, because that's one of our benchmark numbers. They might also feel comfortable with, I don't know, let's go with 25, since that was in our last problem. I will pick, oh gosh, I don't want this to be too easy, 30, how about? Another even 10, and then we'll do one number that's tricky, and that's a good way to start. So I'm gonna do 12, so it's not an even 10, it's not something I can count by 5s with, all right? So in order to play this Diffie, the whole object of the game is to try and get your numbers down to 0. When you've made it to 0, then you know you've been successful. So the whole idea is to show the difference between these numbers. So the difference first between 10 and 25, the difference between 10 and 12, 12 and 30, and 25 and 30. So with something this simple, that we use friendly numbers, right away your kids might be able to tell you, oh, well when I look at 10 and 12, I know the difference between those two right away is 2. And I can also look at 25 and 30, and I know for sure, I trust that the difference between 25 and 30 is 5. Now, where they might get a little bit hung up is maybe the difference between 10 and 25, and they're not feeling as confident. Can you do a place value stack? Sure, maybe that's how I'm gonna solve this problem. And I'll just do it my rough work off to the side. 25, take away 10. I'm comfortable with this. It's actually quite friendly because I don't have to break apart any 10s. I don't have to do any borrowing. I know that I can have 5 ones, take away 0 ones, I've still got 5. I can have 20 or 2 10s and take away a 10 and be left with a 10. So the difference is 15. Okay, and then heading down to my bottom one, the difference between 30 and 12, they might try the stack. Ooh, not feeling confident with this, so I need to have another strategy. So this is where I would say, let's get going with the number line. So I told you before I was more comfortable counting up, so I'm gonna start at 12, and I need to make it to 30. So in order to get from 12 to 30, the first thing I might do is actually add 10, because I can start at a number and skip count by 10, no problem. I can add 10 and I know I'm gonna get 22. I could add another 10, but I'm gonna land on 32, so that's too much. So instead of adding 10, maybe I'll pick, I can go by 2s now more confidently. So I'm at 22, and I'm gonna add 2 to make 24, 2 to make 26, 2 to make 28, and another 2 to make 30. So the difference between 10 and 30 then is going to be right here. 10, 11, 12, 13, 14, 15, 16, 17, 18, okay? And again, I don't want you to discourage your child from doing something like this and adding 2 each time. It might be painstaking, but they need more practice going like this until they can say, oh, right away, and recognize that that's gonna be 8. They need lots of practice. Sometimes they'll go by 1, and you need to let them go by 1. As long as they're getting there and they're understanding that I'm looking at how much space or how many numbers between 12 and 30, then you're on the right track, okay? Now we have our outer square complete. So now the next step and stage of the Diffie is to go this way. Okay. All right, so now looking at this, I know the difference between 5 and 15 is going to be 10. All right. Ooh, now as a kid I might look at these and go, ooh, these seem a little bit scary to me. I'm not quite sure, so I'm gonna lay them out on my number line again. So how about this time? Can you see? I'm gonna go over to the side here. I'm gonna take 15 and 2, and I'm feeling a little bit more confident, so I'm actually going to count back this time. So I know that I have to start at 15 and I have to count back or get to 2 in order to find my difference. So the first thing I'm gonna do is take away 5, and I'm at 10. And then I know, actually, that's really familiar to this. I can take away 8, and I know that I'm at 2. So now my difference is 8 and 5. All right, so I have to add those 2 together now in order to know how far I've gone backwards, which is 13. All right, so now 18 and 2, oh gee, that's really not much different than this. It's actually 3 more. So my difference here, 16. All right, and my 18 and 5, 18 take away 5. I might even just count back for that one. 18, 17, 16, 15, 14, 13. All right, and we just keep going. And hopefully what will happen is your kids will start to see a pattern emerge. So I can see, oh, the difference between 13 and 10, well, that's easy. It's going to be 3. 13 and 10, it's the same. That's 3. The difference between 16 and 13, I can count up. 13, 14, 15, 16. The difference is 3. And the difference between 16 and 13 is 3. And what do you know? We should have a difference of 3 take away 3 is 0, 0, 0, 0. We've made it to the finish line, 0. Okay, so that's how the Diffie is played. Depending on the skill level at which your child's working at, choose really difficult numbers. So I used 3 relatively friendly numbers, one that was a little bit more challenging. I would encourage your kids to continue using friendly numbers, at least 1 or 2, until they get confident subtracting or adding in order to find a difference. And then depending on grade level, you can also make these 3-digit numbers. So if I wanted to, I could turn these into 3-digit numbers. Maybe I keep 1 2-digit number, and I get lots of practice doing this. You'll need a little bit more room because the Diffie will become more involved, but it's actually a lot of fun, and
If they're not making it to 0, then you know that there's been an error somewhere along the way, and they need to go back and find where they made the mistake. So hopefully this makes sense. I can always come back to subtraction. If you have any questions, please reach out. I've had lots of people contact me and say either this worked or can you explain this a little bit more. But yeah, Diffie hopefully will be a game that you guys can play that doesn't require a whole lot of actual material other than paper and pencil.
All right, so it's a different day, different hair, different outfit, but I'm just finalizing this video on subtraction as a difference. And I think the biggest thing I want you to take away from my lesson is that that place value stack is the end goal. It's efficient. That's maybe how subtraction works best for you and you understand it and you get it, but we have to build our children's understanding of that sequentially. And I don't know about you, but I always remember following that procedure as a kid and being, sitting next to, and I could name him right now, Alex Crowley, if you're watching, sitting next to a kid like Alex who was able to just fire out these answers and it took him no time. And I could never figure out how he was able to do that so quickly because in my mind, I'm taking those numbers that are in the problem, I'm stacking them on top of each other, and I'm crossing out a number, I'm adding a 1, I'm doing all of that in my mind, and I'm never fast enough. My guess is a kid like Alex or those math thinkers, those math minds, are they're skip counting. They're finding the difference between those numbers using some of the strategies I laid out for you on the number line. They're able to do it mentally, and that's why. They're not stacking numbers in their head. That's not mental math. So we want our kids to be confident in their abilities, and we want them to have multiple strategies for coming to an answer or solution. So it's not that they're never going to do that. It's not that new math and the number line is taking over the place value stack. It's that we want to build an understanding so that they can feel confident in what they're doing. All right, so we'll talk to you later. Maybe one of these days I'll be back with the F word. Fractions. See you guys.